Hello everybody, welcome back to Glaciers and Glacial Geomorphology and to the second part of our introduction to Glacial Geomorphology. In the first video we talked about Glacial Geomorphology being the story of processes, landforms and landscapes in glacial environments. We talked about the way that glacial conditions determine the processes that go on and how those processes control the landforms that then go to make up the landscapes. We also talked about the fact that you can reconstruct former glacier characteristics on the basis of the landforms that they leave behind, whether they be erosional, depositional or composite landforms. We also talked a little bit about how the geography of landforms is very specific to the geography of glacial processes, and we talked about the way that glacial landscapes were time transgressive, so the characteristics of an environment would change over time, leaving behind a record of the evolution of a glacial landscape through those periods of time. So previously in this module we've been talking about the characteristics and behaviour of glaciers, and we've covered all those topics like mass balance, thermal regime, dynamics and so on. In this final third of the module we're going to talk specifically about the effects of glaciers on landscape. So geomorphology is our focus, specifically glacial geomorphology, in other words the landforms and the landforming processes associated with glaciers. So we're interested in glacial environments, the geomorphic processes associated with them, the landforms and landscapes that they create. And we can look at those in two different ways. At the bottom of the figure here you can see I have a causal relationship, or a set of causal connections between the characteristics of the glacier, for example its thermal regime, the presence or absence of water at the bed, the shear stress at the bed, the thickness of the ice, all these different characteristics that we've talked about previously. And those glacier characteristics cause certain geomorphic processes to be effective or less effective in those different settings. The existence or otherwise of those geomorphic processes causes certain landforms to emerge, and assemblages of landforms give us our glacial landscapes that we're interested in. But we also made the point that you can work the other way up that diagram, and by looking at a glacial landscape or a set of glacial landforms, you can interpret those, you can read the landscape to figure out, well, what processes must have been operating to have created those landforms. And then you can work out, well, if those processes were operating, what must have been the characteristics of the glacier or the glacial environment in order for those processes to have operated? Must the glacier have been moving? Must it have been warm based or cold based? Must there have been debris in the basal ice layer? All these things that you can work out about a glacier by looking at the landforms, looking at the geomorphology that the glacier has left behind. So one really important thing for you to do right now, and you're familiar with me constantly saying draw your conceptual map of the course, keep track of all the different topics that you're learning about in this module. Well, now's an opportunity to put that into a slightly different application. What I'd like you to do is work up and down this list that we've just gone through: the glacier characteristics, connected to geomorphic processes, connected to landforms and connected to landscapes, and start filling in details under each of these headings. Some of these you'll already have from what we've done previously in the module. For example, all these things in the top block here we've already talked about. Others we've only touched on and are topics that we're going to talk about over the next few weeks. So down here under geomorphic processes, landforms and landscapes, you might not yet have a huge amount of experience with those, but start filling in a table like this now. Make yourself a chart, start filling it in, and even if there are blanks in some of these spaces for the details and for the examples and for the case studies, you can at least have those sat there ready and waiting for when we talk about specific topics over the next couple of weeks. So maybe just pause the video for a minute, copy this down or print this out and use this as a basis for making a chart or a table of your own that you can fill in specific examples and case studies on as we move forward. As we move into this section on glacial geomorphology, it's a good opportunity to just step back for a minute and think about the context of your studying glaciers in the broader context of your overall degree course. A lot of you doing this module are doing a geography degree. So as glaciers people, why are we studying geography? Not just why do we study glaciers as part of geography, but what's special about geography? Why is geography such a fantastic subject to be studying? And for a lot of people, the first answer to that question is, well, we love geography, we're studying geography because we're interested in landscapes. Some of you in previous modules with me will have been directed to read that work by Andrew Gowdy about great landscapes and the impact of aesthetics on geomorphological interest. A lot of people get into geomorphology, get into geography, because of their interest in exciting, interesting, aesthetically pleasing landscapes. And that's a perfectly valid way to get into the subject, and it's a perfectly valid focus for your particular interest in any area of geography, rivers, volcanoes, or in our case, glaciers and glacial geomorphology. So as geographers, we're interested in landscape. Well, the next question then is, well, what do we mean by landscape? And for a geographer, landscape, it's a complex term, and it can include a lot of different components. And for a geographer, that can include both the physical geographical aspects of landscape and the human geographical aspects of landscape. And a well-rounded geographer sees those two things working together. And landscape includes both the cultural elements and the physical elements, and those are very strongly interconnected and intertwined. Like this photograph here from Ecuador, there are elements of volcanic landscape in there, and there's also a very obvious component of cultural or human landscapes in there with the agriculture. And the landscape includes all of that. Now, what if we think about just physical geography? What makes landscape for a physical geographer? Well, we still have the applied aspects of physical geography, hazards, resources, management, and so on. So there is always going to be a human component in physical geography. But for a lot of physical geographers interested in landscape and geomorphology, they're keen often to strip away that human context, to get rid of the buildings, get rid of the agricultural patterns, other than that they're evidence for us sometimes of what lies underneath. And if you can strip away those human layers, what we're left with is the topography, the morphology part, if you like, of geomorphology, the shape of the landscape. And if you've stripped away a lot of those human components, then we're looking often at wilderness environments. And a lot of physical geographers do like to work in wilderness environments, not just because of the lack of people, but because the lack of human artifacts enables us to see the landscape more clearly. And that's certainly true of a lot of glaciated landscapes, especially in parts of the world where the glaciers are still present. So here's one of my favourite old field sites in West Greenland, and you can see this is typical of a lot of glacial landscapes, revealing the geomorphology, revealing the landscape without the clutter of human construction, without the clutter even of very much vegetation. You can see very clearly what's going on. You can pick out the components, you can see the bedrock, you can see the patterns on that bedrock, the geomorphology, you can see the deposition of moraine, you can see the glacier, you can see the river, you can see the edges of the channel, you can see the bars within the channel, you can see all sorts of things going on here which are purely topographic, geomorphic, process related features of the physical environment. And for me, certainly, learning to understand the glaciated environments of the landscape that I come from in the middle of England, I had a much clearer vision of how that landscape emerged once I'd seen this landscape on the picture where it is actually emerging right now. So seeing an active glacial environment with all the human mess stripped away enabled me to see much more clearly through the human material when I was back in England looking at the English landscape. And that's one of the points I want to focus on a little bit through the remainder of this video, just talking about how you can see through the surface layers to the geomorphology underneath. There are lots of ways that you can do that from your desktop on your computer screen without having to travel to Greenland and back again to get an idea of what you're missing looking at your own landscape. And so I've put a list on this slide of some different things that you can look at. Basically, go and look at a variety of different maps, satellite images, go onto Google Earth or Google Maps, look at some LiDAR images and so on, or DEMs of glacial landscapes, and try to notice the different ways in which they reveal the landscape to you and the different details that emerge from those landscapes. So I've just put a list there just to begin with. Go onto Google Maps or Google Earth or the satellite image search engine of your choice, and there are some locations there where there are, in reality, some very clear and obvious glacial landforms on the ground. But how easy are they to see through everything else that's there? So if you go to look at the Tweed Valley in the northeast of England towards the Scottish borders, if you look at Oxenholme and the south end of the English Lake District, there are really clear drumlins there, but to what extent are they showing up through the human activity, the agricultural land and so on? If you go to Clew Bay in the northern part of Ireland, the drumlins are more obvious, partly because they stretch out into the sea, so they stand up as islands in the water, so you can see them much more clearly. And there's a variety of different examples there that you can go and search for and see if you can find those using something such as Google Maps. But I'm just going to show you some images now as an example of how you can see more clearly by looking at things in different ways of northern England, and then we'll have a quick look at Iceland as well, just as another example of the kind of imagery or the kind of data that you can see. So we're going to look at northern England using Google Maps, and then using some LiDAR imagery, a DEM using LiDAR, and then look at some published interpretations or readings of that kind of data combined with fieldwork that then represents subglacial landforms or subglacial bed forms of the last British ice sheet in a very clear way. And it'll be interesting for you to compare what you notice first when you just look on the ground or look on Google satellite imagery, compared with the interpretations that you can arrive at having looked at that same landscape in a variety of different ways, including through DEM data and including through field observations. So here are two images of exactly the same location. It's around the area of junction 36 on the M6, heading past Kendal in the English Lake District. And on the right hand side we have the Google Earth image, and you can just about pick out on that some of these topographic features elongated in the direction of ice flow, but they're not very easy to pick out amongst the clutter of the field patterns and the patches of woodland and the fields with different crops in, and the roads and the buildings and the patches of built up land. It's quite difficult to pick out the topography amongst all that. But if we strip away some of the human component and present the data in a different way using this digital surface model from LiDAR data, it's possible to just pull out the topography and to see it more clearly. And once you have seen some of these features highlighted with the careful shading on the DSM, you can then move over to the other map and say, ah, yes, I see it now. There's that feature, which is that feature, and then here's the one next to it, just on the other side. Yeah, there we go. And you can kind of begin to navigate your way around the features, and having seen them on this very clear representation, you can then begin to pick them out a little bit more clearly on that original kind of more natural, if you like, view. If there's time in our live session that's associated with this video for the students who are doing my module, what I'll do is call up these links and run through them with you to look at exactly what kinds of landforms and landscapes we can see by looking at the landscape in different ways. But just in case, well, for those of you who aren't doing the module with me in real life, there are some links here that you can follow to getting different viewpoints on different glacial landscapes that will enable you to see differently or more clearly from what you might see if you're just standing there having a look around the landscape in the real world at a first glance. And at this stage, what I'd really be hoping that you're doing is using resources such as those and Google Earth, Google Maps, just to go and have a look at lots of glaciers and have a look at lots of glacial environments to try to pick out some examples of the kinds of features we've been looking at, either on glaciers or over the next few weeks as we start talking about different glaciated landscapes and landforms and landscapes. Go and look for examples of them. Go and look at Baffin Island, go and look at Patagonia, and go and find the landscapes being created, and then compare those with landforms and landscapes that you can see in areas where the glaciers have long gone. So do some exploring. This is being taught as a geography course, part of a geography course for most of the students who are doing it. So remember that you're geographers, and go out and do what geographers do best. Go and do some exploring of different landscapes and try to apply your theory, your theoretical knowledge, to those specific practical real world landscapes. So as geographers, I guess that brings us to a very obvious geographical question. Where in the glacier does the geomorphology happen? I've been saying throughout that the glacial geomorphology, glaciology, they are very geographical issues, because different things happen in different places, and these geographical connections feed through our interpretive system. We can read the geography of glaciers by looking at the geography of glacial landforms. So where do we look for things going on in terms of landscape formation in glacial environments? And we can divide it into two sections. First of all, we can think about, well, where is the glacier right now, if you like, as it is making its landscape? So if we looked at a contemporary glacier, where would we look to see geomorphic processes going on? And so we might think about the supraglacial environment, the end glacial environment, the subglacial environment, the ice marginal, proglacial, the proximal proglacial, the distal proglacial. We could draw one of those little maps that I keep drawing for you on the whiteboard, where I say, okay, here's the ground surface, here's the glacier, here's a bit underneath the glacier, here's a bit in front of the glacier, and you can draw for yourself a little diagram of all these different positions within a glacier system. And you can think for yourselves about, well, where does the geomorphology happen? And you might say, well, not much geomorphology happens supraglacially, surely, because that just disappears, and so that's not affecting the landscape. Well, to some extent that's true, but on the other hand, if lots of debris is emerging onto the glacier surface and then the glacier disappears from underneath it, then we are indeed left with a supraglacial land system emerging after the glacier has gone. So there's geomorphology going on kind of everywhere within the glacier system. The kinds of things that probably occur to those of you who've done this whole course with me will be the bottom of the glacier, the base of the glacier, the ice bed interface, especially where there's a basal ice layer containing debris being dragged across the substrate. So we have erosion, entrainment, transport in the basal ice layer, deposition from the basal ice layer to create subglacial till, deformation of that subglacial material in a deforming bed context, for example, to create drumlins perhaps. So we're aware from our study of the glaciology of the positions within a glacier where geomorphic processes are likely to be happening. The second heading, if you like, to think about onto this question of where does the geomorphology happen, is to think about the fact that glaciers change position through time. So any one location on the ground surface might at one point be proglacial. Then as the glacier advances, it becomes ice marginal. Then as the glacier advances further, it becomes subglacial. Then the glacier begins to retreat, it becomes ice marginal again, and then eventually proglacial again. So there's this sequence building up of time spell after time spell during which different glacial process environments are affecting that one location. And so we very typically get a palimpsest landscape, a landscape where records of different points in the glacier landscape history are all preserved together or in sequence, so that a landscape is not simply a record of one point in the history of the glacier. A landscape can be a record of multiple points superimposed upon each other and often all existing in the same layer. On top of that, we then also need to think, well, what happens at the end of everything? What happens when the glaciers finally go away completely and that it is no longer a glacial landscape, but we're looking at the processes of deglaciation, the loss of the ice? And what about post-glacial landscapes? Or you may have come across this term, paraglacial landscapes, when the landscape is adjusting to its change of situation after the glaciers have gone. Glacial geomorphology doesn't kind of stop at the point where the glaciers are disappearing. Glacial geomorphology embraces a very wide span, well, a time transgressive span of different things going on while the glaciers are there, as the glaciers are disappearing, and after the glaciers have disappeared from a location. Now I just want to finish this video with two diagrams from the core textbook for the module that lots of you are taking, the Glaciers book, 1999. And these diagrams summarize what's going on in glacial geomorphology, viewing it as a sediment transfer system, because a lot of the geomorphic processes that we're going to be talking about in detail over the next few weeks, the erosion, the entrainment, the transport, the deposition, we're talking about sediment being moved from place to place, and sediment within the glacier doing work onto the glacier bed, or sediment within the glacier being deposited to create depositional landforms. So there are a couple of diagrams in the book that kind of illustrate what's going on in terms of that sediment transfer system. And we're thinking of glaciers in a kind of systems way of thinking. So there are inputs, there are throughputs, and there are outputs of debris into the glacier. And I've just identified on these arrows what these different inputs are: the supply of debris into the glacier, either by wash or mass movement of material onto the glacier surface, stuff dropping out of the atmosphere onto the glacier surface, entrainment picking stuff up from the glacier bed and putting it into the glacier, or erosion, eroding stuff from the glacier bed and transporting that within the glacier. So those are the inputs. We then have this throughput area with transport of debris through the glacier subglacially. For example, if we have a deforming subglacial layer at the glacier bed, basal transport, end-glacial transport within the glacier, and supraglacial on the glacier surface. And you'll see I've got arrows as well connecting these different layers up and down, because as well as the horizontal movement of debris through the system, we can also have vertical movement of debris up and down through these different transport layers. And then for output, where does that debris go when it leaves the glacier? Well, it can be deposited within the glacier system, if you like, deposited subglacially. It can be from the glacier surface, removed by deflation, for example, or it can emerge at the glacier margin and then either be deposited locally, and that's the end of the story, or it can be traveled, it can be evacuated by long distance travel away from the glacier margin, for example in rivers out towards the ocean. And even the stuff which is deposited locally, we need to think about the potential for long-term reactivation of that. I mentioned paraglacial environments earlier on. So once something is deposited by a glacier, that may not actually be the end of the story. There's always a possibility of reactivation, remobilization into the transport system, and then the redeposition of that at some point further downstream or further through the sediment transfer system. The next diagram I'm going to show you kind of picks up on this little central section and just elaborates or enlarges on that a little bit. I said with the last slide that as well as moving horizontally through my model of the system, sediment transfer can also work up and down through the system. So here we have the layers of the glacier: supraglacial at the top, end glacial, basal. Here we have the subglacial layer, and here we have a substrate. So if we have a deforming layer, well, I've stuck in another layer below that to represent, if you like, the ultimate substrate. Even if we did have a deforming layer above that, then the basal ice layer, then the end glacial facies, and then the supraglacial. And you'll see in each of these situations, we're bringing ice and debris in from the right-hand side of the diagram, and then we can move things upwards or downwards, out of the system at the top by deflation, downwards and out of the system at the bottom by the thinning of a deforming layer, which is essentially depositional. These other depositional processes here, moving things from the ice into the subglacial zone. And if the debris is carried all the way to the edge of the glacier, then there are these different mechanisms of moving it out from the glacier. So this is perhaps just a convenient way for you to visualize some of the different things that we're going to be talking about in terms of sediment transfer through the glacier, which is itself a convenient way of beginning to think about glacial geomorphology. A lot of the landforms and the features that we'll be talking about over the next couple of weeks, the drumlins, the U-shaped valleys, the striations, you can fit them onto this diagram somewhere. Certainly if you include also this previous diagram, the two diagrams together, you should be able to identify on these where all of your different glacial landforms, erosional, or in fact there's a challenge for you, try to fit all your erosional and depositional and composite glacial landforms and landscapes onto this diagram. For those of you who are doing this, watching this video as part of my undergraduate module, this is the kind of thing that would be likely to come up in any kind of test or end of module workbook exercise, asking you to provide specific examples to go of landforms or key locations to illustrate or demonstrate the kinds of things that are going on in these diagrams. So that's something for you to think about as follow-up work to this video. Well, that's all I want to say about glacial geomorphology for now. We've got another 2 or 3 weeks of work on glacial geomorphology to come for those of you that are doing the module. So hopefully a good number more videos on glacial erosion, glacial transport, glacial deposition, the processes involved in those, and the landforms and landscapes that emerge from those processes. And like I said at the beginning of this unit's videos, I'm particularly interested for you to be thinking about the connections between the landforms and landscapes that we see coming out at the end of our model, if you like, the connections back to the characteristics of the glaciers that are creating those landforms, because the characteristics, the dynamics, the morphology, the geography of those glaciers is what's driving the geography of processes, which is what's driving the geography of landforms and landscapes. So ideally, when we look at a glacial landscape, we should, amongst other things, be able to infer the characteristics of the glaciers that created it. And that's what we'll be exploring in more detail over the next few topics in this module.